make it happen. So thanks for coming, everybody. I am the presenter in this go. I'm also the chair of the Advanced Users Track. Thanks for coming. Give us feedback after the sessions. Let us know what you think and how we can improve. So today, I'm just going to tell you how this is going to go. I'm going to give you guys about, 15 or 20 slides, and then we're going to do an exercise. And the goal is that I'm going to show you some things on how and why you would want to do object-oriented analysis and design, and we're not going to do it in LabVIEW, we're going to do it in diagrams, class diagrams, and communication diagrams. And don't worry if you don't know what those are. I'm going to give you a short crash course on that. And then I'm going to present you guys with a problem. A customer wants a solution, and he's coming to you as developers to build a solution. And so then we'll break up into small groups. My goal is to have people who describe themselves as experts lead each group. We have, I think, 8 big Post-it pads and Sharpies and some tables at the back, and there's a table on the side there, and there's a table up here. So I think we'll mostly be able to be around the tables and writing. And then I will challenge you with a couple of exercises. One will be trying to come up with new user stories that gives us a reason to make a change to our software. And that's going to test how well you did your design, or if you considered that change in your design initially or not. And we'll go down that path a ways. I've got a few already written down ideas of additional user stories that could be built into requirements. But I think it'd be fun to try to get some from you guys, and we can hopefully iterate on our design at least once, and then maybe if we throw, after we do an iteration of our design, just sort of talk about what additional requirements or user stories, how it would require us to change our design, or how it would challenge our design, or if our design is already well suited to handle it. So before I start, so about me. So I have been writing software in LabVIEW since 2009, and the last 6 years I've been employed by Phoenix Nuclear Labs and pretty much working on one application, which is particle accelerator control system. And we're on our 5th different machine now, and we're building 4 this year. And so along the way I've written everything and thrown it all away because I saw a flaw in the design. And my design cycle up until like this year has been like a 1-year design cycle. So I have the time to identify a flaw in how I'm doing it and do a refresh. So the machines I build are similar but different. They're for different applications. And because of that similar but different, I have invested in object-oriented programming and actor framework programming. And then as an aside, I'm also a cycling coach, and we're going to see some cycling things through through the presentation and our hands-on experiment is going to be cycling related, and it's not me in the launch screen. If you've tried the LabVIEW NXG. So, how many people here are object-oriented programmers? How many people here have done object-oriented analysis and design? How many people here, what tools do you use to do your design? Anybody? A notepad. Google Toolkit. White Star UML. I use Lucidchart primarily, UML tools. I tried doing the reverse engineer on using the Google Toolkit on my project a while back, and it was a little too complicated. So that was an older version of it. New version might be. So Steve Watts mentioned that he can do presentations by just doing Google searches and piping the results into images. And so I kind of do the same thing. And if you look closely, if you do an image search for spaghetti code, I don't know if up in the upper right there is probably, as Fabiola calls it, the VI. Which is when your application is one VI. Oh, there's that right now too. So in the upper corner there is the LabVIEW version of spaghetti code. It's actually a little unfortunate that because it's a graphical language, you can actually see that it's spaghetti code. Maybe it's fortunate, right? Because like, if you write it in a text-based language, you can't just look at it and be like, you've got major issues. You have to like, if you read books on refactoring, and you read the code and then they explain like what they identify, it's like, the text-based stuff is just, it's a lot of words on a page for me. I don't know. So, I looked up spaghetti code, and then I had to look up pejorative as an add-on there, because the definition, I just love it when definitions make you look up other words, because, I don't know, I guess I'm an engineer and not an English major. So expressing contempt or disapproval is a pejorative. So it's a phrase that expresses contempt or disapproval for source code that has a complex and tangled control structure. And so, if we design our code well, we won't have that. That's the goal. So, I already asked this one, I guess. So let's. I didn't ask why. Why do you do analysis and design? The three people that said they do it. Dimitri, why do you do it?
I need to have a plan before I start coding.
So, with hearing that, so Dimitri said, I need to have a plan before I start coding. So now, if you think to yourselves, who here tries to come up with a little bit of a plan before they start coding? Okay, so you've all done some analysis and design, but maybe it wasn't as complete as you.
Your question was object-oriented.
Okay, yes. Okay, so yeah, that is fair. I did say who's done object-oriented analysis and design. After today, you will have. Everyone can answer they have. So here's my answer. So analysis is about finding the objects and organizing them, and then describing how they go together. How do they interact? what is their interface? What is the signature or the contain of the VIs that I'm going to be calling? How do they behave? And what kind of data do they need to contain in order to do their job? And so then that's the analysis portion. And then design, you have to apply some constraints. So is there a hardware or software platform that you're on? One of the constraints we have is that if you're writing it in LabVIEW, we don't have some of the other languages constructs. So you have to live in the LabVIEW realm. Other languages are not complete either. So there is no like one mega language that does everything. There's choices, and that's a constraint. On top of that, as you can read, performance, usability, budget, and time. For me, like performance, that comes down to, I'm doing machine control, I might have timing constraints that say I have to do something on the FPGA. I may have safety constraints that say my electrical engineers need to do something in hardware. Or that say, now that there's this new SIL-rated module, I have to use the SIL-rated module. And then there's usability. Who is this for and what do they want? So there's all sorts of design, but what we're after is probably, hopefully, good design. And so this is pretty much API design here. So API, I had to look this up a few years ago because I don't know how many of you are software engineers by schooling. I'm not. How many of you are some sort of engineer by schooling? How many haven't raised their hand yet? There's like 3 left. Okay. What's yours? Neuroscience. Physics. Chemistry. Physics. Okay. So I have math and molecular biology. And I don't know how I ended up where I am, but here I am. So API, SCC, there's just alphabet soup out there. People need to communicate. API is Application Program Interface, and basically the way I think of it is API are these arrows between your pieces. It's how do the pieces work together. And when Fabiola says the VI, it's when it's just that yellow box at the top. That's the VI. Maybe you get a little bit of breaking up because you can see where they discovered control references and you pipe the stop into a whole bunch of things. And nobody's ever done that, right? Okay. And the other reason I think that we all kind of have to use API is because we're not writing binary, right? At the end of the day, what are we interacting with? Even if it's like an analog module, it's really like there's an A to D converter, and we're not interacting with that. And then, there's an FPGA, and we're not interacting directly with that. So we have an API that we are interacting with when we're using LabVIEW, because all of those VIs are an API to some underlying thing that probably has another API or two between it and the ones and zeros. So, has everybody read through the bullet points on there on why we want good design, or should I go over them? You all can read, and they're 2-word phrases. What's the question? So what I mean by hide implementation is that essentially private methods. So an API to a class, which I'll go into this in a little bit. Maybe let me save that, okay? I'll come back to it when I cover what a class diagram is, but that's I'll hit that point. So first I'm going to cover some things about classes and class relationships. So this is from the UML 2.0 book it's one of the O'Reilly series books. And if you're going to do UML diagramming, I would highly recommend this book in terms of, this is just like one little figure in a multi-100-page book. Who is the author? It's at the end of my presentation.
Is it Martin Fowler?
It's at the end of my presentation. So, I'm not good with memorization. I can't remember, like, I'm lucky that I can remember Kurt's name, and Dimitri's name, and it's Brian Hooper, and Ray, right? So it's like I can finally get names after a while, and like the keynote, did anybody see that I was in the keynote? Like I had to memorize that. It was kind of memorized, but I had to like reduce it to bullet points, like, thank you, you know, like, and then I could build on that. So anyways, the class relationships here, I'm going to cover the first, the strongest class relationships, which are on the right there, inheritance and composition separately, and then the weaker class relationships, the dependency, association, aggregation, I will talk about kind of lumped together. But how many people here have heard of inheritance in object-oriented programming? How many people here that have done object-oriented programming, this is the compelling reason to do it, right? How many people did object-oriented programming because there's private data and private methods? Yeah, so encapsulation. So I'm just trying to, I think most people start with, I want to do something, and then I want all of the things that are like it to implement it a little bit differently, and maybe call the parent method too, and that's like a main use case for getting into object-oriented programming, is inheritance. But I think the second use case is encapsulation, which is the hiding implementation, is you expose a public interface, but then how you actually do it is private. Composition. How many people here use object composition? So a class has another class, or it has an array of another class. An object, correct, yes. A concrete instance of a class, an object, has in its private data other objects of a type. And then the rest of these, owns but shares a reference. So how many use aggregation? We'll just go through these definitions. So a class has an object has an instance of an object of another class inside of it, but it lets another class use it, and then it doesn't. The other class that uses it doesn't own it. I saw some hands up. I think a lot of people use association where you work with objects of another class. I would say this is actor framework. I mean, I'm sending messages. An actor works with a message, sends it to another actor, and then there's some data exchange, but the purpose of those classes was to like mediate transmission of information, but they don't necessarily own the message. They generated it, and there's a recipient. And then objects working of one class work briefly with objects of another class's dependency. So with inheritance, this is the is-a relationship. And so these are, I'm going to give you the easy way to remember these, okay? Is-a, inheritance is a. And Dimitri, I left off of here, boat, and then the boat with 4 diesel motors that Dimitri programmed. But I have an example of vehicle and wheel vehicle, and then I guess the class that I don't have is the unwheeled or non-wheeled vehicle, and then under that would be a boat. And then somewhere is the boat Dimitri did. How many have seen Dimitri's presentations with boats in it? Okay, so it's sort of an inside joke. So a wheeled vehicle is a vehicle, a car is a wheeled vehicle, a truck is a wheeled vehicle, a bicycle is a wheeled vehicle, so on and so forth. So classes on the top are not concrete. They are a concept of a vehicle. So as you go down, you get into the concrete implementations. So this is another set of phrases: abstract and concrete. So abstract. Well, you can read the slide. So when you build a real system, you're usually going to use the abstracts to define ways to do things, orders to do things, ways objects work with one another, and then you're going to launch a concrete instance of one of those things, and it's going to actually behave and implement methods and do something. So the next weaker association is composition, which is the has-a. This is, I think, where most people make the mistake of not going to object composition soon enough and trying to use inheritance and realizing that they have an instrument that, you know, it is a power supply, and then it's like, oh, it's an RS-32 power supply. Oh, it's an analog interface power supply. Oh, it's an analog interface power supply with the RS-232 interface too. What do I do? You know, what does it inherit from?
Multiple inheritance.
Yeah, multiple. So my solution is it has a interface. It has a communication protocol. So here, a bicycle is a vehicle. A bicycle has wheels, has a transmission, has steering, and then on the bottom I put some more is a for the transmission. Is a single speed, is a multi-speed, fixed gear, free wheel, internal shifting, external shifting. So there's all sorts of, you can have a bicycle that has a something which is a concrete instance. So you're going to find that there's going to be relationships within the contained objects within an object. And this could go on and on. So a transmission on a bicycle has a crank, has a method of getting the power from the crank to the rear, but it might be a belt drive or it might be a chain. So it can go on and on in terms of the way these objects can be built up. Whether or not you have to do that is a whole nother question. Like if you're designing a system that has a model of a bicycle in it, do you need to model the amount of strain on the threads of the spoke to the nipple and the material that the nipple is made out of? Is it brass or is it not? And then what about the interface with the rim? You know, you could do that if that's your problem domain. Where if your problem domain is like, I want to apply a torque to a hub and I want to see the stress on the spoke, then you have to do that. But if that's not your problem domain, maybe you don't have to go that deep in terms of describing what you have.
I can make something into a class, but really it's quantitative. There's no example I just do that and going, okay, multi-year, single speed and multi-speed, well, that means gears and how many gears is the class? The gear, or the operative class is the gears, and only a number of gears is a quantitative gears.
So, my response to that is in a future slide, but it's basically, there's multiple right answers. So I have a slide later that kind of addresses that. But, you know, we're unique individuals. I don't expect us all to have the same answer. And the customer can be happy as long as the program, the application, does the right thing. But your design could be better or worse or more robust to change or more susceptible to being broken with a new request, depending on how it was designed. The usage I wanted to cover here too, so like a user, you know, works with a bicycle, probably wears a helmet. I'm a cycling coach, competitive cyclist, and I have my coworkers show up with no helmet on. And I'm just like, you're a PhD, like, physicist, plasma physicist, and you have no helmet on. Usage. So use a helmet. And here, a bicycle also will interact with a course, but the course could be a trail or a road or a track. So there's all sorts of different types of interactions that you can have. Next I want to go to, I'm going to change gears a little bit from the class relationships to the earlier question about the hiding implementation. So, encapsulation. So, a class is a combination of data and the methods that operate on that data, along with a way to interact with that class. So the API to the class is the campaign of the public methods. And maybe you could argue that it's also the campaign of the protected and community methods when in scope. Who knows what the different access scopes are for LabVIEW classes? How many access scopes are there?
4.
4. The answer is 4. So there's private, protected, community, and public. Okay? So community, the class has to be listed as a friend of the other class in order to call that a method that's in community scope. Protected, the class has to be an ancestor, it has to inherit from. Public, it can be called anywhere. Private, it can only be called within the class itself. So what that allows you to do is is if you have a VI where my example is, let's say I have a scaling VI, and and the signature is double in, double out. What actually happens inside is none of the developer's business. I mean, well, maybe none of the user that's calling that scaling module's business. It's the designer of the scaling module's business to make sure that the scaling does the right thing. And after that's tested, it doesn't matter anymore. And if something changes that says, I need this method to be more performant, and you go in and you refactor, the signature, double in, double out, doesn't change, but because of encapsulation, hiding the implementation, the end user doesn't know what changed inside the black box. So that's one of the advantages with class structure, is that you package the data that the class is going to work on, the interface, the signature of its methods, and then you have these different access scopes of the methods so that you're not exposing everything to everyone. Does that make sense? So encapsulate what's likely to change. So the method, or the thing that I think about here is, if I have a scaling is, I'll just use scaling again. Okay, so I want to have a bunch of different scalings. I have a logarithmic scaling. I have a ion gauge that has a formula that if it's this exact number, that's an error code. If it's that exact number, it's an error code. And then between here and here, it's this exponential. The user doesn't know that. The class that calls the thing to scale the data doesn't know that. The designer who designed the system and says, this object, this concrete instance, has this concrete type of scaling, made the decisions. But now I can use a template that says, I'm going to acquire some data, I'm going to process the data, and I'm going to pass it on to the rest of my system. The scaling can belong in a template now. So which scaling are you doing? Well, it's context dependent. But now my code is flexible because I have a class that is like a scaling class that defines a signature, and then I have a linear scaling, which is a y equals mx plus b sort of thing that somehow got configured with what m and b were, and then I have an exponential scaling, and I can write those is a inheritance classes to implement the scaling method, and it's hidden. Are there any questions on that point? So one other thing about encapsulation is in your API, your contained design, think about where you might need to encapsulate or have the API be a class in or a class out. So it's not always the case that you're just going to be using LabVIEW primitives, a numeric, a double, a Boolean. You might be wanting to have a template that you don't know the data type, but then you write a concrete version that has a concrete data type hidden inside of it. So you can think about that, right? So you can't do object-oriented analysis and design without knowing what the design is supposed to do. You can't do design without some idea of what you're designing for. So figuring out what it needs to do to work properly is your job in interactions with the customer. The customer may be your internal engineering team. It may be somebody that has hired you to do the work.
Or it may be yourself.
It may be yourself, yeah. So like, for me, I have some requirements that, like, I want to use the template I already have. So I have to, like, play by my rules. So a good way to get requirements is to have use cases, and this is kind of, this is borrowing from Agile. It's as a, state your role, I want such and such, state your feature, in order to accomplish something, some tangible, valuable thing to you. So use cases are those types of statements, and the reason they're made is because you can assess them and they have value. They have starting and stopping points, and they're usually triggered by something. I'm going to mention it here too, that you ain't going to need it. Abstraction for the sake of abstraction, or turning everything into, every interface into an array of a class with, you know, where anything is possible, any inputs could come in and any outputs could be generated, and it could launch an array of anything that has an array of anything inside of it that could do anything, is complicated, confusing, and probably doesn't get the job done. So you want to constrain yourself to things you know you have to do or you think are likely to have to be done. Things that are unlikely to have to be done, you don't do them until you have to. The other thing about requirements is a well-written requirement. You can test. The system shall do such and such. That's requirement speak, not use case speak. You can test and you can know if you are done, if you have to write any more software. What we're going to be looking for in our hands-on is identifying all of the pieces of that and how they go together. So it's kind of identifying the different shapes and the shape of their interfaces. We're going to use two types of UML diagrams in our hands-on, and I'm just going to cover them quickly. The class diagram and communication diagram. And this is actually an inheritance class diagram of diagrams. So the class diagram, this is a bicycle. So here you can see that it has wheels, which are of type wheels, transmission, which is type of bike transmission. It's divided into three sections. The top section is the class name. The middle section is its data. In LabVIEW, for better or worse, the data is all private, so there's a minus by each of those. You can create a data accessor, new VI for data access, and then that would show up down in the bottom. Then the bottom section are the methods. And I mentioned on the side there the public, private, protected, and community scope. The plus, the minus, the pound sign, and the tilde would go in front of the methods when they're of a different access scope. And then a communication diagram. So I kind of did two of them here. The top one is a simplified version of what the bottom one is. So, and actually the bottom one is really just the bicycle to court. Well, no, I pull in the user too. So, a user has inputs to a bicycle telling it to go, stop, and turn, and the bicycle gives back resistance and vibration data. And the bicycle, in turn, has input to a course, which is go, stop, and turn. And the course gives you vibration and resistance information. But in reality, if you break it down a little more, the user is actually only interfacing with the pedals, the seat, and the handlebar. And the pedals are interfacing with the drivetrain, which is a chain or belt, and then the rear wheel. And then the rear wheel and tire are interfacing with the course. And the rear wheel interfaces with the frame, interfaces with the seat and seat post, and gives you vibration information. So the vibration information is only transmitted through, well, it is transmitted through the pedals too, but like the resistance information is only transmitted through the pedals. I didn't put all the labels on what the arrows are, but you can see how you can break down these problems in more than just, you can do it simple, or you can do it more complicated, and what you do depends on what your problem is. So the solid diamonds are has a. So a bicycle has a pedal. It actually all of the things on there, I could have drawn those solid diamonds for all of the has a parts, because pretty much all those white boxes are contained in a bicycle. They're all has a relationships. Not in this example, but in a real bicycle. What's that? What about a triangle? Oh yeah. So if it's an is-a, it's an open triangle. And we'll not get bogged down in the details with the arrow conventions, because I think we'll do a little bit of class diagramming, and then we'll do a little bit of this communication diagramming. And then here, there's more than one answer, okay? So, find X. Alright? I just like this one. So, I'm expecting, we're going to break up into groups next. And I'm expecting that you guys are going to give me some different answers. Yep. So I'm not really showing you that, I'm just sort of showing usage here. So like, the bicycle is a composite of multiple components, but it's all shown in just one blue box here. And it's interacting with the course, and the course is just shown in one orangish, pinkish box. So I want to get the hands-on started. So I have two documents to kind of. So what we're going to do in the hands-on is a local to where I'm from, Madison, Wisconsin company, Cyclops. They make bike trainers, smart bike trainers, and they are an industry-leading bicycle trainer manufacturer. And they actually have their own software, but in my hypothetical here, they're asking us to design a software package to interact with their new trainer to provide an exciting and engaging user experience. What I want you guys to think about right now quickly, and then I'll show you my notes, is what do you think about, and can I get a volunteer to write some things down maybe? You got some big pads in the back. Somebody, John will do it. So Sharpies and pads are in the back. What do you think what are the necessary parts? Can we just do a first draft as a whole group, and just well, let's just get a list kind of started, and then we'll break up into groups. And then I'll put up a Word document that I have that has some more detailed user stories that are going to drive you down a path. Okay, so some of the parts.
Just a quick dumb question. I assume a trainer is like a stationary question.
Yes. We're going to start, so you're wrecking part of my extension already. But, so let's start with a stationary trainer that's like one unit, like you go to a health club and you get on a stationary bike, okay? Let's start there, and then we're gonna, there might be some obvious extensions. A screen.
VR goggles.
Write it down. So in preparation for this, I will add that I met with the software engineer at Cyclops and talked to them about their system. And he explicitly mentioned VR goggles. Anyone else? A way to adjust the resistance.
App connectivity.
App connectivity. I don't think we're going to deal with the mechanical of the bike. I want to focus on the software that's going to control it, and I'm going to give us some user stories. Let's talk about exciting and engaging user experience. What are some of the features that you think you would have when you're interacting with a trainer, because you're forced to ride inside because it's too hot in Austin in summer or it's too cold in Wisconsin in winter? Ride profiles. Speed and distance.
Ride with your friends.
Video. A wind machine. Virtual coach voice.
Cloud service.
Other cyclists.
Cloud service.
What's that?
Cloud service.
Bottle service?
Cloud. Cloud. Compete with other people. Compete with other people.
Compete with other people. Bounce around when you hit virtual rocks. Social media. Performance enhancing drugs. Okay. 75-watt motor in the down tube. No wait, they scan for that now. It's got to be in the rear hub. Oh, they scan for that too. Strava integration. STRAVA. How many King of Mountains do you have?
5.
5? Okay. Oh, signaling lights? Signaling lights that tell us which way we're going. Something like that. I don't know if I'm understanding your comment right here. Okay, let's curb the. Let's stop now and let's get into groups. So we have almost an hour and a half to do this, but I want to challenge you guys with some changes in the middle. And if at any point anybody needs to stretch their legs or go to the bathroom or whatever. The bathrooms are like literally right out of this door. I think men's is that way and women's is that way. So there's some tables at the back. I'd like to get a group at each table in the back. There's a table on the side there that I think we could throw some chairs around. There's the table up here. And then there's a few easels in the back. So if you're not at a table, we can arrange some chairs around an easel. I think we have 8 or 9 of the big post-it boards. I'd like to get 8 or 9 volunteers as object-oriented analysis and design experts to lead each group. John's a volunteer, I'm a volunteer. Who else? Don't be shy. If I invited you because I wanted you here to be an expert, you should. Okay, so experts, find a table in the back, make sure you're not with another expert. Intermediate and novices, find a table with an expert. And I'm going to put up and read off some of the user stories that I think we'll start with. But obviously doing this little shout out exercise might give you some ideas of things that are likely to change. Okay, so we're going to have to be able to select a workout. We're going to have to communicate progress. We're going to have to consume a profile, or the workout is going to have a profile. So there's two types of profiles that we're going to start with. One is a GPS-based file profile, and the other is a profile that specifies duration and percentage of threshold power. For all of these, I want you to assume, and this is the way it works, that the trainer, all you have to do is send it the resistance that you want it to go at. All right, and for now we'll just pretend that it does that on command. Okay, so we might have to figure out some attributes for our users in order to figure out what resistance to send the trainer. That's our job. Okay, and then think about what you would want in order to make it interesting for you. How many people here regularly exercise? Okay, so how many of you use any sort of training devices when you're exercising? Heart rate monitors, GPS sensors, average speed, power meters, cadence sensors. So those are expected in an exercise device. You're expected to be able to interface with the suite of sensors that are normally hooked up to a user. So let's just start doing some design.
Do we care about like a particular type of rider? Like, do we care if somebody is a professional versus an amateur?
No, that pretty much gets
That's in here.
Yeah, that's pretty much the only number. Weight and FTP combined to do.
Has anybody
power per
ridden a smart trainer with
which is
like
considered
Swift or any of
Yeah.
the guy who has Strava KOMs has? So I'm just trying to gauge how experienced people are already. It's okay if you're not, because it's an interesting challenge.
These
You
two
may need
combine
more voice of
into
customer.
what is generally considered the most important, or these two, functional threshold power and weight combined into watts per kilogram, which is considered, because is essentially like useful power. Like, I am more powerful than a lot of Tour de France riders, but I also weigh 60 pounds more. So, like, my raw power output is pretty much on par with some of these guys. And, like I'm a track cyclist, so I can put out a lot of power for a very short amount of time. But because I'm a big guy, I'm also going to take quite a bit more measurements. So that's actually how they scale. That's how they scale the speed within the virtual environment. It's essentially you've got a weight, you've got a power. We will make assumptions about air and road roughness and all these other things. Make assumptions about all the others, and we'll create a visual structure that says because you're putting out this much power, you're going as fast. And that's how, then they speed up or slow down the video. It's either a video or a little animated character.
Would I?
Yeah, I agree. Those are, they're not really a software company. You could email the trainer, like the result or just land right. Yeah, maybe get used. Well, and then you could but our displays would change. We're good.
structure.
I'll go to that. I was going to go.
Yeah.
Okay.
Display the input information, like what's called the profile up there. Is that a separate thing, or is the workout an aggregation of sort of the input, which would be the profile, or the output should be the progress?
And this level workout is something that interacts with the cyclist, with the trainer, with the equipment, and with the monitor, because it needs to get feedback from the monitor. So that would be probably our center profile. Workout is a workflow, in other words, right? We will be designing that workflow and implementing it with a class. So workflow is the primary candidate for a class, right? Would be an abstract class, we need to define workflow information, what it does allow to set in workflow, and how does workflows interact with bicycle with the participants. Make sense?
I think so.
Well, and I think they're separate. I think the output is separate.
Well, I think what he's saying is that, let's say the profile, it might be an object, but it's a portion. I mean, what you're saying is if workout is a workflow, then an input would be one participant in the workflow. Is that the way you're thinking?
Can you repeat that?
Yeah, so if a workout is a description of workflow, then the profile,
So you're setting the value of
the cyclist is supposed to be doing, would be a portion of the work of the
It's a test
or
sequence.
input to the
It's a
workflow.
text sequence for your sequencer, right? It's one implementation of a workflow. Well, it's not an implementation. It is one of the workflows. Your whatever class workflow is, it will be executing one profile at a time, and it will last for like 10 to 15 minutes or whatever. So you have the code of the sequencer, your test stands, and you would inject, you would pass it to the object which is called the profile, and it will start executing that object, interacting with all the participants, right? Can you think of another way to structure it?
profile editor, right? And it has input GPS, right? That can be a function, right? So we can pass this profile editor a GPS and a profile, right? And then we can have
We're going to have to add all your resistance, your speed, and other items into the profile.
That wouldn't be in the editor.
there's no
That would be in-
speed. So yeah, there's no speed. We're just setting the resistance, right?
Right.
The profile just changes the resistance as the workout progresses, right? Either based on the GPS track or based on our set points, which we're going to be for this amount of time do this, for that amount of time do that.
We don't need a bike.
So potentially,
That's the time.
here's a thought. What if our profile, the set points are part of the profile, but they are not part of our profile class, but our custom profiles? That sounds better, doesn't it? So let's have.
We also need to monitor if you move or the outback.
So let's have parent, right? Parent. This is a parent from the class, right? And it's going to have a method that says get resistance, right, which lets us set our resistance.
Oh, that's a detail. We're at much more abstract.
And then our children, right? So we use that open arrow for children. So we got one child that's custom.
And it will be harder to extend
And
your
our custom consists
design
of
when
a bunch
the requirements
of
change.
set points, right?
Okay, so what we have here,
Those set points have a time
we
associated
have
with it.
the
Yeah, time and resistance.
And resistance.
And resistance. Then we have a GPS.
he's interfacing with the software.
And this get resistance, we're going to override it. So this get resistance is going to be based on our set point and current set point, right? It can work through the whole list of set points
It will be
somehow,
monitoring
right?
the cyclist.
And then this will have a get resistance that gets the resistance from the GPS. Does that make sense?
So we have a bike,
All right.
we have a
So what
cyclist.
we're going to have at some point is,
They interact.
anybody ever heard of something called the factory pattern? Yeah? Okay. So in our program, right, our program is going to interact with the parent class, which is this profile, right? The factory is going to create a profile, right? So we're going to have something that comes in. This is going to be our factory. And it's going to produce this wire coming out of this VI is going to be a parent.
Profile is a different thing.
Right? So everything downstream knows it's getting a parent profile. It doesn't care if it's a GPS or a custom. It could be GPS or custom. Right, and then we're going to iterate, right? So this is like your while loop. Right? We're going to take this, we're going to say, get resistance, set resistance. So that's basically what we're doing. As the program's running, we've got this parent profile that comes from either a GPS tracking or some program, right? And then we get a loop that says, okay, every however many seconds or whatever our loop rate is, we're going to read the resistance from the profile and we're going to set our output resistance.
Within this. And see, Mark, this is so beautiful. This is where we screwed up, and this is where we started over again.
You're not alone, everybody's doing the same thing.
Iterative approach. That's right. All right. So we've got all the requirements that now disappeared? I hope so. Okay. So we've got the basic display.
So I was going to say,
We've got the basic requirements. So now the next, try and remember the next step. I have a bad memory, so I look things up by cheat. I go, oh yeah, these are the steps that I need to follow. So we have a structure that I try and remember each step. Yes, exactly. So let's set the attributes to the nouns, and then we can say has a or is a, but we have to also do that with the verbs. We have to link them. So once again, so let's start with this. So we know person. User is a person. So it's kind of backwards. So user, and then coach. So then we've got these three. It is. Workout has profile.
Displaying the display. So, so we'll just say UI. Okay. So it's a UI object, and then it is going to be it's going to be using the session. So that would be a. It's not. It has a session, or no? It's not. It doesn't own a session because it doesn't instantiate a session. It interacts with. What was the?
You're going to select to work.
Right.
Dependency, right? It's an arrow.
Is it a dotted arrow dependency? Yeah. Okay. Because the UI might be, maybe it's the coach's UI, and he's going to flip through different sessions of the people in the class and look at Bob and then Joe and then Al and see what they're doing. So, yeah, dotted dependency. That makes sense.
A plain arrow was uses a. Seems like this user interface is being used by. Or not.
I wish you could bring up that slide again.
I wish we had.
I don't. I almost never write down when I do these things. We'll call it good for now. We can change it. All right. So the UI And then there's going to be more than one type of UI. So there's going to be one for the cyclist and one for the coach. We kind of figured it
So
out.
I just have a couple comments.
So have it.
When you're showing the connectivity between classes, don't get bogged down by language semantics. You don't have to show me a message class or any of that. Just arrows between the pieces that are working with one another is sufficient. We're not selecting an architecture here at all.
You're going to plot it on a map, right? And duration is just going to be a scrolling thing,
right? A bunch of numbers on the screen.
But there all be elements.
So the UI. Do we break it down into the cyclist view and the coach view first? Because I imagine that then the cyclist view will break down into scrolling, 3D versus just data display.
Right.
So
it seems to me their user interfaces are significantly different and don't need to be one in the same class.
Well, we just have the main UI, but we each have one.
Well, you need Well, I'm imagining maybe more of a sub-panel type thing where you have a UI and then you have a sub-panel in it where you inject different UI, like Jeremy was talking about earlier.
One sub-panel would be the cyclist, and one would be the
cyclist UI, which is a UI, and
right.
the coach UI, which is a UI. So
right.
You
yeah, you can do that too.
All right, so
in terms of class concept way.
We can definitely go to another page if we run out of space, and then.
So that's output user interface as input and outputs. Is that right? So you're all thinking about that being output.
Yeah, maybe. Probably.
Which assumes you have to take it right.
User data.
Yep, the idea of a user. So I'll just put down user.
Yeah, the profile.
So that's a good start for attributes. Either that or there's a database that we go to and we actually say, give us a list of those. I don't know if we want to go down that level or not. Let's start here and work up. So in my experience, you try to design this thing 100% up front. You're going to spend too much time and it's going to be wasted effort. So try to get something working first and just iterate. This is a great example of why you want something like test-driven development, where you pick a feature and then you write a test that'll prove the feature exists, and then you write the code that make the feature happen. That helps me to think through how to automate. We'll talk about that in a minute. So let's stop there. Attributes. Let's go ahead and think about methods. So what was it? So remember, this may or may not be the HMI. I don't know if you ever made that decision for sure. To me, it seems like we may want to have a controller object that acts like our model. We may want to have an HMI object that acts like our view. And decouple how we visualize versus what we visualize.
The controller is like the engine.
Yeah. But that said, we could still make an argument to put something on there. Like, what was your idea? Time. Time. So
it could be like a check time.
Yeah, you can like an hour. So I already wrote time. This is permanent or time sheet.
Whatever the sensor is.
Cyclops is going to be concerned. Someone's going to bring out a competitive product in 6 months' time.
So one thing, kind of a code smell. You guys know what I mean when I say code smell? So as you do design work, and it's outside of Google, as you start to put designs down as an architect, you start to develop a sense for code smells. And code smells are usually a flag that something in your design can be improved. I find that a code smell loop is if I find that all my methods are setters and getters that I may have bad class design. In this case, we may not have just added the real meat yet. Because of all we're doing is getting and setting data, where are the methods that actually act on the data and do work to make the class do exist. Does that make sense? So, what could we add in here that would actually do a calculation or something?
GPS will be on the side as another child, an extra hour. Just like the GPS.
So we're kind of missing that.
Yeah. Because GPS has its own
trainer. GUI, right? GPS.
The interface.
Yeah.
GPS
is display it. So the main
It's altitude
controller. It's kind of. It's like a thing we use a GUI. So when we're climbing at a certain rate.
Yeah, and so what does the GUI contain?
How hard it is. You weigh and the grade.
Okay.
The grade of the road. At least those things. There may be some additional things that I challenge your model with.
What were those 3 things? Did you say?
So, resistance is the thing. Okay. So there's resistance due to
and weight.
Resistance due to the profile says that I'm supposed to be at 50%, so that's the resistance. Or resistance. I'm going this fast.
Okay. Then
and I weigh this much, and the resistance due to gravitational pull and or air resistance are what?
Okay, so the person is going to have weight as a property.
That is for
and
sure.
What was the third that we're defining?
Grade.
We're defining
resistance. The person, the weight is definitely an attribute of the person, but the grade is an attribute of the profile. If it's a profile that has that is like a
So we're using profile as an aggregation of step. It's going to be a collection of step objects to define the profile. So then step, I've just drawn, we need to have a step now broken out here. Does everybody understand what these are? So these are going to be our properties, and these are going to be our methods here. And so a step is going to have certain properties. Thank you. A step is going to have a properties. What are the properties for a step?
So, realistically,
grade.
Air resistance.
Can we say every step is grade?
Yeah, everyone willing to carry.
Yeah,
I don't know. Speed. I guess speed. Speed and grade.
That way.
I don't know. A step doesn't.
Weight comes from the person.
A step doesn't have a speed.
No.
Because that's just how fast the person is.
But air resistance.
Actually, you got to calculate it constantly.
No, does it have a resistance?
A certain amount of time, or it is a GPS based profile. So I don't think this correct. The coach can create profiles.
I don't think every step has a speed.
External to the software that we create.
So, of some format that is consumable by the system, but it essentially is the profile that. So a coach profile is a type of profile, whereas a GPS profile is another type of profile. The GPS profile is going to calculate resistance based on your speed, so wind resistance, some model of resistance for speed, the grade, of the profile, which is a function of where you're at in the profile, which is a function of the speed you have it going,
So the way you,
and then how much you weigh.
The way you create your GPS profile is you take the graph, you record all the inputs from the device,
So
and then it becomes the profile that you recreate on the
So you can go on a lot of apps or use a Garmin or whatever and get a GPX file.
Okay.
And so it's going to consume a GPX file that was obtained by whatever method, and that is your source data.
This is one way to do it, but you don't have the quality of data.
That's a very good thought. That's one of the things I'm going to add.
That'll deal with limitations.
But so I don't want to put words into everybody's mouth. I'm telling a lot of people that, like, in my mind, the key is resistance that the model calculates. And the resistance that the model calculates depends on attributes of the cyclist and attributes of the profile.
Where do you get attributes of the cyclist?
How much does the
He has a
cyclist,
profile?
Well, the cyclist weighs so much. Because that's important for GPS. Because if you're out going up a steep hill, and once you set it up, and you're producing a certain amount of power, and you have a certain cross-sectional area, then you'll have a certain amount of resistance. There's a model that is running somewhere that is figuring out what the resistance must be based on some inputs.
No, I mean the actual, like,
I would say so. No, I think it's something that you enter as a user, as a cyclist's attribute. So
yeah, so a cyclist has a profile, chooses the name, available profile here on the screen. The cyclist selects a profile and the workflow executes. Does a coach monitor the cyclist?
Depending on what type of profile, we have a different
in future.
Usually, so the general workflow is after the fact, the coach will look at the data.
Okay. So we at least need to generate some information.
Right. We need a performance log or something to add, I think.
We gotta read it. We can't just.
Okay.
Okay. I'll give some more. I want to make sure people are far enough, and then maybe we can.
Okay. So in this.
If you want a GUI module for each of these, GPS with a custom, what's the best way to implement that? Does the profile own a GUI module, and then depending on which one of these they set the GUI module?
Definitely an option. I mean, I would suggest that there's probably a coupling between some underlying concrete elements and the user interface.
Yep.
And that depending on what concrete instances you're using, you want your user interface to behave a certain way. How you do that is up to you. But yeah, part of being engaged in the experience is to have a good GUI. And the GUI should be informative based on what you're doing.
No.
So where are we at so far? You've got your custom, you've got your GPS profiles, and they both have git resistance.
Yep.
I like it.
Yes. And then we have basically a factory pattern that we have speed sensors, timer, and heart rate pulse. And then we have a loop that basically just reads our sensors and our timer. From the profile, calculates the resistance and then updates the resistance. And somewhere in here, when it reads the sensors, it will update the GUI.
What is the second thing? It's timer?
Yeah, so we have
Okay. So one thing you don't want to forget is the particular user's profile. So the attribute of the user it's going to be important for the GPS profiles because it's going to determine how hard it is. Because if you weigh 400 pounds and you're going up a 20-degree incline,
himself.
Yeah, that's going to have to go into the model, the resistance model.
Okay.
And then if another attribute of the user that has to go into the model for the custom profile is that rider's ability level, so his threshold power. So you don't make somebody do way more watts than they're capable of. So there are some user weight and ability, which is functional threshold power is a common cycling input metric that coaches understand. So don't forget those. And then can you go back to your input? So you got those sensors.
Yep.
It's the next page, I think.
Yes, you got
Okay, yeah. So the heart rate belongs to the
general sensor class, and then the controller owns a bunch of general sensors.
Okay. So I would suggest that probably there's sensors that are assigned to a user. A user may have an array of sensors, and then there's sensors that are part of the trainer.
Yeah, we can't break out the speed
The speed sensor, yeah, but like the heart rate sensor, I'll add some requirements pretty soon here, but.
Okay.
So we got heart rate, pulse center, O2,
but generally, a user could have an array of sensors.
Okay.
But then the system has some other sensors.
Besides speed and timer?
That was
What I'm saying is that's separate.
Actual resistance might be another, like actual load.
I thought we had that. Yeah. We had that as a feature at one point. Oh, right here.
Like, I want to be able to choose the workout, and then when I'm doing the workout, I want to be able to see where I'm at.
Okay.
I'm halfway up the mountain, and I got a lot more to go.
Assuming that it's a touchscreen. Well, right. Well, no, you said that. Display allowed you to select the workout. Display command.
Oh, so now you've got display which has input and output.
Display is actually the same.
So my understanding is that workout contains an object called data. Data simply has properties that you actually toss into storage. It's a buffer, it's memory, it's data. Data then, the object has multiple methods that allow you to export this data to multiple different things. You can have a method that says export HMI, export to a telephone, to a cell phone.
So what we're doing now is we're defining the classes and the methods. We'll get what you just described is the next step. We're not quite there yet.
But that does define how we think about our objects.
Per cyclist, a profile that's a duration similar to this. It's a overlaid.
Okay.
Right.
So
Or is it exclusively his choice whether the person is going to do 2D or 3D workout?
That's where we.
Or are you saying it's a scaling? It's a scaling.
I think it's a scaling.
It is a scaling of the profile, but it has to be per user.
So is that private data of the cyclist?
The coach would probably be the person who creates the profile.
I think so.
But let's say I come in and he's not there and I want to exercise. I should be able to load the profiles that he selected for me to use.
So the coach presets this. Bob is at 50%.
Well, we're going
so
night
load him. His max is this.
So my only heartburn here is
that's one of the reasons you use
global setting or
object and class-based programming.
When you say it's a global, like everybody today is getting the same punishment.
Yeah, I
But that there might be premium information that is stored. It keeps track of your body mass. Sure. Interesting idea.
And we can try to let's work in
You could have spaces for those
If you find yourself doing that, I would say it's another group, right? So another nice rule of this is if you're let's say this was going to be an interface class, and you find yourself with data or methods in your interface class that some children use and some children don't, it's usually a good tool to change your design. Again, it's a solid principle. It's called the interface segregation principle. So these are not hard and fast rules, but these are good things to keep in mind when doing this design work, because they generally put together a good way of solving that is you create another the video profile class. So I would say that maybe this is a good place for like an NPC type architecture, where we have a profile and a profile view, and they're tied together with a profile ID, right? So that way we can have the visualization data here for the same like resistance or whatever other data is here. 15 minutes total. Actuation. That way, this guy doesn't have to concern himself with how you visualize the data. So our HMI, we call.
Then I challenge the ideas, and we talk about it.
I guess our P and designs gets us to a better
respond well.
So MVC is a can of worms. Model view controller. Has anybody looked into model view controller before?
Okay, I just want to make a quick announcement. What we're going to do is 5 more minutes of small group time. Then what we're going to do is these 3 groups are going to kind of huddle up, and you're going to share with each other your design. You 2 tables there and you 2 tables there are going to share with each other your designs. And then, so that way we've kind of explained our rationale to somebody else. Then after, we'll do that for 15 minutes. That's my hope. We'll take 15 minutes explaining to just one close group nearby what we did. Then I'm going to scroll down and show you some of my other ideas for things that I would think would make it a more engaging experience, etc. And then I want to have people discuss if their design, like I'll take volunteers, whose design is robust to that change and why, and whose design is fragile to that change and why. Okay? So 5 minutes from now, I'm going to make us kind of huddle with your neighbors.
I feel like we got percent of FTP. No, we essentially think of it as like a series of like a movie script. It says at this time you will be doing this percent.
So actually, the course would probably be feeding back.
Well, I guess that's not percent of FTP. It's because the resistance it would either. So
I have a gradient, really.
It'd be a gradient.
Just because you're either going straight, you're going up, or you're going down.
No, that's actually, because percent of FTP is for his workout profile there. Because it's the virtual ride versus the kind of artificial.
Yeah.
Because the kind of artificial thing is where you get into the weird thing versus for resistance. Because resistance, you're trying to make an assumption of how much power the person is going to be putting out, going up a gradient. So that's more of a model. Whereas the other one, I know exactly how many watts you should be doing based on how large you are and how you need to keep that prediction.
Profiles to assign.
And they actually also use the profile.
So we're confusing and it has to be the same one that's displayed, right. The same one where it uses profile for display.
No, but coach enables a different setting for display. And you're talking about coach the actual person using the punching in profile.
Yeah, what would be the difference?
Because one is like the actual class image and software, and the other coach is pushing.
Okay, you mean but you mean the abstraction part. But still, there are two kinds of people.
I think the coach has an ability to create a profile, but I don't think they necessarily.
In a class diagram, you would not use it.
I would think
he just creates.
And assigns the process for
What?
and assigns it to an
And assigns it.
So, all right. So let's imagine this. So the display says, "Who are you?"
But you may not need to.
We choose whatever. Based on that, it chooses to either receive and profile in.
object, and it would execute its model, resistance, whatever, and it would pass this data to the actuator. It calls, this is called, inside, and this is uses. On the diagram, uses. This would be uses. You pass it to the model, it uses them. And inside the model, you call this thing. And it also takes input from the sensor, which would be a bunch of drivers interfacing the hardware.
So that's a uses also?
It's uses because it calls them. All it subscribes to the events, whatever model we choose. This level, we're not talking if we use public subscribe or direct call, right? This may be a bunch of vectors, this may be a bunch of vectors. We're not talking about this right now. Okay? And then you have your GUI, which I don't specify one display, another display, follow lens or whatever. It's a GUI, and all it does, the model, dumps the information on the GUI. So, in this model, we can later split the GUI into two, one for
What if the profile provides?
or in the original version, the GUI may be a log file, right? You're just dumping data into a log file. And your GUI have different implementations. And by adding those implementations later, you don't need to change the model to do different displays.
So is that the same thing as the display subsystem over there? It's just a different name?
That one?
Yeah.
Yes.
Okay.
Okay. What else? What are we missing? So that would be model types.
So that's for the models for the resistance control, effectively, right? So then you'd also have a independent for the infotainment aspect. Like, for example, if you were playing music or had, I don't know, I'm asking out loud. So like if you have a VR, is that considered like GUI? Because it's not necessarily the same thing as like the out. I'm thinking as a separate thing from the model. The model is controlling resistance, right? Like let's say we switch,
controlling resistance
right,
and interacting with the bike.
Right, and I'm thinking that there's another piece that's missing, which is the sort of the user-facing, like the cheering crowds that you're going by, or the competitors you're racing against, or that
So
kind of.
that means we need to rename that box. It's not just a GUI.
Right.
So what would be the right name?
The user experience model, or the
yeah. What's a good word?
Experience.
VR model, VR.
Yeah, VR model, that would make sense. Sure.
Yeah. Or augmented reality. Well,
Yeah.
there is no sense of augmented reality because you don't need to see the road. There is no road.
Right.
Okay, I want to have groups merge at this point, okay? Merge in LabVIEW doesn't work. So, try it anyways. Yeah. So, if you're, just expand your circles maybe, and then have the leader from each of your groups have a go at explaining your design to the other group. All right. So let me know that my design rocks that, like no change needed, versus oh man. I can't do that at all. All right? So go ahead.
We have basically two main parts of the system. We have a controller, and then we have the GUI display. And we kind of have a dialog box that kind of kicks it all off. You either pick from two different options. You can either do GPS, where your profile is based off your GPS, or custom. And we actually need another dialog box before that to add the user.
Yeah, so put the user weight in.
So you start, you enter your name, you put in, this is my username, this is whatever you write, and then you pick GPS or custom, and that produces a profile. Right? So a profile, you do GPS or custom. The custom one has a whole bunch of set points. The GPS just has all the GPS data. And that profile provides a resistance. So that's like your desired set point. And then once that kicks off, for each of these you have a different degree. GPS, it outputs a GPS profile, GPS GUI, or if it's a custom, it outputs a custom profile and a custom GUI. And the custom is like 10 minutes at this speed or this resistance.
So you're generating profiles on the fly? Or
Yeah.
do you use prepared profiles and just select?
Yeah, so the custom, the editor for that will allow you to put in a time and a particular resistance. So 10 minutes of this resistance or that resistance. And there may be in the editor some prepackaged ones. Say this is a ramp up, ramp down.
And your trainer will come with a system.
Yep. And then we take our controller, we initialize it with the profile, and it runs. Basically, it goes and how am I doing?
We got 3 minutes. You're 3 minutes in. It might be this one. Isn't that the first one?
So the run, what you do is you read all our sensors. So we read our auxiliary sensors, for the byte, whatever they may be. We read our speed sensor, our timer, and we read the user has some sensors, the heart rate, GPS, or whatever he has. Right? So we read all that data in, and then we look at the profile, we pull out what the resistance should be, and then the user has some scaling function in that resistance that's based on his ability. So that scales the resistance, and then we set the resistance in the bike. And then we send an update to the GUI. And depending on which of these two GUIs we have, that determines how that data is displayed.
So was the custom resistance modifier part of the step?
That he came over and told us to add that.
So that's a change.
Changeover. Big money, right? So yeah, that's our whole idea.
Okay, so I think your session idea is one level better than ours. I think that's all right. And then for our profile model will hold like the resistance data. Our profile view would be maybe a map that you could put in the HMI that would relate to the resistance data. And so you could see, they could show where you were. And we created a profile controller that would be in charge of which profile and which view were actually being used on the system at the time. And then we talked about MVC for a while. So
that's what we were after too.
Yeah.
The session was our model, and then the UI is our view.
That's pretty cool, right?
Great. Ours is a little, we didn't get the shows that far. We went through an iterative process. We tried to simplify the architecture, the design, so we went through 3 iterations already. So we came down with very minimalistic approach, so 3 classes, a user class, workout class, and an output class. So in the user, we had 3 attributes. One is the age of the user, the weight of the user, and the capability, which means whatever level they're at from a health point of view or whatever point of view. In the workout, we said workout has a profile and it has manual entries. From the profile, we used to have 3. So we do have 2. Sorry, that's why I looked black, because we did a 3rd round. So we have preset is a profile, and user-defined is a profile. So you have two types of profiles, whether it's preset or you can enter it and define it as you go. Some methods associated with this is to actually run the profile, so that's the ride method. But you can save the profile, and you can also load the profiles. And I'll get to the other arrows after. So the third method, class, which is the output class. The output has progress and has a display. We also have a display method for the output so that we can view it on display. The display also communicates, there's a communication method to communicate, whether it's to communicate to the display or to communicate to the coach. And also we have display the thresholds, if there's any limits that the person should be within the user. So from the user has a link to the threshold and also has a link to the workout. And the workout has a link to the output. So the user has a workout execute. And the workout generates an output that is then sent to the coach or is displayed to the user itself. And that's as far as we went. Oh yes, sorry. The sensor. We considered the sensor as a future feature that if the user has wireless sensors that he wants to send the data to the trainer, we would be creating the hooks for that future implementation.
First step, we identify the participants, and here the interactive parts, which are the bicycle, the cyclist, sensor, screen display, the coach, and workflow. You need those for the stories. Yep. And then we establish graphical relationship, how the interactions go. And from this interaction, we drew a top-level view what kind of classes and interfaces we need. This is our application is called Sweat. So this is our software. I like it. Yeah. Who came up with the word?
Here's the clever words.
You did. The guy in the back.
Okay. So it's Rob. Rob!
I won't take that.
Your application name is well, God appreciate from the other people. And these are the interfaces through which it's not necessarily software, but it's a translation of software through which the application interacts with the participants. And then we started looking at what the
Are you guys almost done sharing back there?
Yes.
Yes? Okay, let's
5 more minutes?
5 more minutes?
We need a couple more.
Okay, a few more minutes. Everybody go huddle around whoever's still sharing then. I don't want to talk over everybody or somebody else, so we'll go a few more minutes.
Okay, so this is the Sweat application, the class diagram, and what it gives you. The centerpiece is the workflow engine. That's like it takes profiles as an input, and profiles may be of different types. This is parent of GPS profiles or a code-generated profile, for example. Workflow doesn't matter for the workflow which one you pass it because it interacts with the interface. And then you have systems for display, for sensor input, output, etc., etc. And the more concrete part for the workflow part is the model. It actually computes everything. It takes all the inputs from sensors and works on the actuator and to properly function each cyclist parameters and the profile description. So that's the 2 input it's needed. And then it starts running. And when we discussed, we thought it was a it should be displayed. Then some use cases said that it's not just displayed, maybe audio, it may be social media. You may want to put some Twitter, streaming there. So we decided this is a VR subsystem or multimedia subsystem. And you may implement it in different ways. You may have one display for the coach, one display for the cyclist, or a HoloLens on the cyclist and display for the coach, or maybe just a log for the coach.
So where it's a VR something that's more like an implementation or like an interface?
It implements the interface, but it does not specify what it is.
That's why it's in the 3 at the bottom.
That's why you have inheritance and unpredictable, something less. And at this point, we need only to describe the interface, what it allows to output. For example, sound, images, etc. So each type of the output may need separate set of methods. And at this point, we didn't define it. And then, again, model is an abstract class which allows multiple implementations. And when you start your web application, you actually in the configuration files or in the dialog, you choose which implementation you want to run, which model. Model that takes weather into account, that takes something else into account, like pavement quality, to generate resistance, etc., etc. And then it would probably seem more like this model would be what you define with the further level of detail. Okay, questions?
What did you? What about the GUI layout?
What?
The GUI layout. Is all voice and?
We didn't define it.
I had it over there. Okay.
We said we may want a virtual reality device later.
Okay.
So we don't want to define the GUI now. The concrete implementation would be injected into the model.
Okay.
And you could make that depend on your profile. So depending on what profile.
No, depending on my equipment. Whether I have VR goggles or not.
Okay. Dimitri's going to integrate Alexis into it.
So that doesn't change them based on your profile. For whatever GPS or custom, you get the same display.
GUI doesn't know about profile. It only knows how to display information that model wants to display.
All right.
Okay.
Functions underneath.
So, how about being able to compete against past performances? Can anybody's system play back a previous performance? Yeah, so if you have saved a performance, it should give you like your location on the GPS, or maybe it's recorded your speed the entire way, and so it can plot your progress, and then you can have your current progress, and you can see the difference. Okay, I would like to track my improvement over time. So again, if you've saved your performance, you can see improvement in multiple ways. As a cyclist, you actually probably want to keep track of how your threshold power and or your workload has changed over time. There's some training metrics like training stress score, acute training load, and chronic training load that you would want, but those are more. Okay, so I would like, let's see, I'm going to skip the one about precision. How about, I'd like to ride with other people on the same course at the same time. Can anybody's control system support an array of users? You have a method for that. Okay, you had a method, but you threw it out.
Had the method.
Okay, so I think like this design that I saw, loads a workout profile, there's a workout session, loads a cyclist. All this needs to be is a one-to-many relationship, and it could load an array of cyclists. Now, if we go down there, how about, now that I'm riding with other people, how about drafting? I want drafting in my model. So how do you deal with drafting in the model? That is right. It's air resistance. So you need it. So whose design can substitute the resistance model? Dimitri's. So to me, the model in my mind, the model is really a sum of resistances. So I would probably have the resistance be either one number that can call into an array of other models and then like add it up, or it could. The other thing is it has to be able, if it's going to support multiple users, it has to output an array of resistances potentially. So I used to own a cycling training facility with 17 combi trainers, and it's computer software that could control all 17 trainers simultaneously. But there wasn't air resistance. That's sort of an aside. But it's one of those things that. So if you're going to run a workout session for yourself, let's say it's your home use, right? And how many people here can, their design, you could have a heart rate monitor, right? Now what if your significant other wants to ride the bike? Can everybody's design support a separate user?
Yeah, we have age, capability, and weight attributes to the user.
Yeah, so your system probably needs to have an array of users. Right, and then you select your user. Your system probably has the ability to add a user, and then adding a user would have various attributes that you need to fill out. How about changing the angle of the trainer to simulate climbing and descending position? Who here has seen the commercials for that Pro Trainer?
Yeah, you just get the profile.
So here's an issue with that. It's a hardware issue. So what is the output from your system to your trainer? I said it was resistance, right? But now it's resistance plus angle.
This is the output to the pedal, to the resistance to the pedal, but not to the visual.
I'm talking about, I literally put the trainer on a thing that can tip forward. They made this. This is a real thing. Not all trainers do this, but
in our model, the profile is the Z versus X, essentially. So you multiply it by the ramp, and you have the weighted course. Yeah, physical position, the innovation, like...
I'm not denying that you can calculate it. I'm just commenting that if you have a change in hardware, who here has thought about what is the communication profile or protocol from the system to your trainer? Because what I I know, but let's just think about it. So no, I mean Bluetooth. I don't mean what is the communication, what messages within your framework. I mean, how are you commanding that physical piece of hardware? Are you using Bluetooth? Are you using FE-C? Are you using ANT+? What is the protocol that you're using? Does your system have a flexible, assignable, essentially, protocol per trainer? So if you have like this thing here where you could have your workout session where you're loading multiple cyclists, the cyclists would be assigned. So here's another thing, you have to assign sensors to a physical trainer, piece of equipment, and then you have to assign the user to that trainer, and then this user has sensors. So there's some interesting, there's some...
to the profile.
What?
We could have a sensor input to the, this is sensor to the output, sorry. Yeah, we have manual overriding of the workout. That means that there is a capability to adjust the profile on the run. And that's
So,
the most
okay, I'm going to give you a few more. How about, so there's a manufacturer that makes buttons. This exists. This happened. And you want to simulate shifting on your stationary trainer by pressing these buttons. And so then your resistance model will change. So these are just things to think of. And maybe your user interface will change. The VR goggles, to go back to that, you get them sweated up, like, you'd use VR goggles for about 5 minutes, and then you would regret having VR goggles. The other thing to consider that we didn't really talk about, somebody said something about wind speed, like a wind machine. We're not going to buy like $1 million wind tunnel, because you could, right? An interesting one that I saw on John's design here is a simulated trainer for testing it out. But I actually have something down here farther that is, as a parts manufacturer, I'd like to enter parameters for components and have a simulator change the performance based on the physics of those parts. So you have a way to have things enter into your resistance model. Because if you supported a resistance model that's modular, then your resistance model could get super detailed in terms of the aerodynamics of the rim, the aerodynamics of the spoke, the aerodynamics of pretty much everything. And then you could add in things like yaw angle of the wind, etc. So you could get pretty complicated if you wanted to in your model, and then at the end of the day, you just output a number. There was another one that when I was going around, how about like bumpiness? Is there a way to simulate bumpiness? The one that I was thinking of too is wheel slip. Like let's say I'm off-road, and I want to simulate a mountain bike ride, and I want to change the friction model of the tire to the dirt. Where would that go? Whose design could support, I think it would go in the profile, right? And so it would be the resistance model. How about a camera to see your cross-sectional area, so that you could adjust resistance based on how aerodynamic you are. And then I want to show you a really funny video, because this is what we're going to end on. I just have to move it over to the other screen here.
Oh, the Superman.
Okay, so this is my motivation for the aerodynamic sensor. Who's seen this video? Has anyone seen it?
There you go.
Okay, so this is why you need the camera.
Do they show the motorcyclist?
See how much more aero he is than those suckers that got their legs down? So now he's gonna bridge up to the guy that's in the breakaway. He's like, I don't know why his pedals are going around. I guess it's probably friction in the chain. Hopefully not a down-tuned motor. So now he hasn't had to pedal at all, right? I mean, it's a little awkward though.
Watch the motorcyclist gets in the action here in a second.
What's that?
Right?
Oh, I want to do that too.
There's the funny part.
I remember it. It was fun.
Okay, I got one more video. So this is another idea for a user interface. How many of your designs could support using a toaster as the interface? As the resistance generator, as the load. So this is Robert Forstman.
Oh yeah, I've seen this one too.
It's too bad Nancy, can you, the button on the lights, the top left button, it's a black button, like all the way to the left, It's just a little, it's a button, not a slide. It turned them on before. I was presuming that it might turn them on. So this is a different interface. So
there you go. He's powering the toaster.
So he's going to power a toaster, and when they press the button, there we go. Now we're at about 700 watts, and now you can see they're going to adjust the grade that he's on. Equivalent speed 50 kilometers an hour. This is a world champion track cyclist.
Yeah, here he goes.
So one thing I should note, how many people, well, we all had heart rate, right? So now they're increasing the grade, so his RPM is going down. I always bend my handlebars like that when I'm riding.
Yeah, like you got forearms like that, dude.
How many have seen this video before? Okay, viewer. I'm like, you guys are all watching videos instead of doing work.
Yeah. Spending as much energy as you think that goes. Oh, more. You can't even do it.
So now the funny thing is, he's I think he's 1.7 meters tall, so that he's like this tall. My legs hurt hard. Look at his legs. So 21 watts.
Oh yeah.
See how much shorter he is at some point during the day. He's like a gymnast that got into biking. All right. Well, that's the end of our time. So sure. Dimitri has a minute for a comment. Is what we're doing here.
Thank you, Casey. It was a great experience, something we all had fun, right? Let's get the round of applause. And now I want to switch back from fun and fool's day videos, like with this biker, to software engineering. And as you know, I use agile software design principles. And those principles, and I actually try to bring them to the LabVIEW community. And there is a philosophy under those principles. And the philosophy, in short, is called
constant refactoring. And Uncle Bob, the author of the book, says, make your design the best you can do it today, and don't try to anticipate changes tomorrow. And if you're using solid design principles or agile design principles, you have good chances that refactoring would come at incremental cost. So the use case which Casey was peddling to try to anticipate a lot of stuff, I would advise against going that route. Just get the book, learn the principles, and do the job that needs to be done today. And then your code will be good enough, so when changing requirements can come, you will be able to quickly refactor them to those specific requirements. Because if you try to guess the requirements, what will be needed a year from now, chances are you will be wrong. And you will spend time on designing the plumbing you don't need, and then you will spend time taking the plumbing out.
As usual, if you're going to be here for the next session, rescan your badges. So, out and around.
What reference?